Hello again. Okay, so back to my education reform, how I would up the system. Mathematics. This is going to be a tough one. So in the past, literature and history, I have suggested we just need to slow them down a bit. Go into a little more detail, split up the courses maybe. Can't quite do that with math the same way. You can, but it's more difficult. Math builds on itself, so you have to learn a certain amount before you learn the next amount. So we can't just slow it down, because by the time someone graduates high school, we expect them to have a certain amount of math under their belt. Or do we? Now, we could try to break things down a bit. Sort of decide you're going to need X amount of math so you can be in the slower track. Where this guy needs more amount of math. We're getting the dystopian type thing where you sort of predetermine people's careers when they're young. I'm against that. But we could look into that a little bit. Just, again, based on how well, we can have different tracks of math. People who show an interest in the more technical stuff that needs math take the more detailed track. People who don't show that interest at a young age take the less detailed track. We're sort of locking people into career paths, so I'm sort of against that. That's one way we could look at it. But other than that, how do we do it? Because, believe it or not, most people need the math that they take. Most people, algebra, when am I going to use algebra? Believe it or not, you use algebra all the time. You just don't do it as an algebra problem. Now, story problem. Here's the thing. We should have started off algebra with story problems. Person A starts at this place at this time and is traveling at this speed. And person B starts at this place at this time and he's traveling at this speed. And when will they meet? Well, let t equal time. Then we start breaking things down into algebra problems. Which, story problems, we learned them like 4th grade. We didn't treat them as algebra problems. Perhaps we should have. Without going too deeply into algebra, we should have at least set up the basics. Because the big thing about algebra, we have x, the unknown. And it makes sense if you're looking for it. But most kids started like, we're trying to do math with a letter instead of numbers, and how do we do this because this isn't what we learned. And because x, it stands for nothing in most of the problems. X plus 5 equals 7. Yeah, we can solve it easily enough, but it throws people. Why are we throwing this letter in there? Do a story problem. Now x represents something. Like, t is time, x is whatever. We're trying to solve for something. T is the number, or x is the number of apples we're buying, or whatever, with the money we have. Now it makes sense to some extent. We set it up as a story problem. We show the algebra behind the story problem. We tell them what x actually stands for. It's not just some generic variable we threw in the problem. And we solve it as a story problem, like I've been saying. After a while of doing this, we turn around and we say, okay, now we're going to start doing the more abstract. X is just a random number. The problem doesn't necessarily make sense. Like I said, we do algebra all the time without thinking about it. We want to travel somewhere, we got to meet someone somewhere, got to be here at a certain time. It's so far away, how fast do we have to travel to get there? And we don't really sit down and do the math word for word or number by number, but we are on based on past experiences estimating things. And so, and we're not using actual numbers, but we are using estimates of the past things. we are actually doing algebraic type problems on a day-to-day basis. Okay, I'm running late. How much do I have to speed up to make it there on time? Again, we aren't doing the math per se in our head, but we are still setting up the situation as a algebraic type problem. So yes, algebra is more important than people think it is. Do we actually have to do the math to do it though? Because again, people make these estimates all the time, and the answer to that is unfortunately no. But there are still going to be people who want to move on to a higher career and need more math. So we have to do it at a certain rate. We do get into some stuff, Geometry, we can do that on a separate track as other things, although learning geometry gets us thinking in the proper frame of mind to do algebra, perhaps. Calculus, yeah, we're going to need to know a certain amount of algebra to do calculus, so algebra comes first. Trigonometry, we need geometry before we do trigonometry. We're going to use a little bit of trigonometry in calculus, so it sort of fits in between. So there is a order we should be doing math, teaching math in, and most schools do teach it in this order. That works for us. So the big problem with math is, I talked about Common Core math earlier because we were going to get into it a little bit. And so we do sort of have to go back to elementary school on this one. Like I said, my reform series, I've been sticking more to the high school level. But we are going to have to go back to the elementary school and start teaching things a little differently there. Fractions. We have to simplify our fractions, we are told. Getting to college, you don't have to, depending on the course you take. An architect has to simplify his fractions. No one wants to read, we need 72/15ths of a foot or whatever. They want you to break it down, simplify that into whatever that would be, which I would have off the top of my tongue if I'd actually done that example ahead of schedule. 72/15ths I said would be 4 and 12, I believe, 12/15ths. I could be off on that one, doing it in my head real quick. Math. So, but you get into the other sciences, we don't care. 3/2, yeah, physicist doesn't care if you say 3/2. In fact, rewriting that as 1.5 would just make the equation bulky and unuseful. So we tell people you have to simplify fractions because sometimes you do, but then you grow up and you find out that you don't always need to simplify them. It's only in certain cases. So when do you simplify them and when do you not? You have to rationalize your fractions. You cannot have an irrational number in the denominator. 1 over the square root of 2 you're not allowed to do. So you rewrite it as square root of 2 over 2. Basically you're multiplying by 1. Square root of 2 over square root of 2 equals 1. Multiply that by your 1 over square root of 2. You get square root of 2 over 2. Again, physicists, we don't care. Because we run into pi in the denominator all the time. And pi is an irrational number. So if we're not going to rationalize pi in the denominator, why bother with any other rational number or irrational number? So, yeah, grew up, learned all this stuff in elementary school that we have to do, followed through in high school, which we have to do, got to college, and no, we don't bother with it. But again, there are other times when you would want to do it. And that's one thing we have to do, looking at math, not just telling how we do it, but telling why we do it and when. Which again slows things down a little bit, but it's sort of an important slowing down. So that's it mainly. I mean, I could go into all sorts of other weird examples on what to do or how I would do it or how I would change things, but it really comes down to, like I said, Common Core, the basis for it or the supposed purpose for it, I agree with what they say online. But then you watch the examples of how they're teaching it and it's questionable. And I would say we do need to rethink how we're teaching things at an elementary school level, but we have to at the same time realize that we are going to have to do things at a, that can be easily transferred to a high school level. And the way they're doing core, again, yes, their purpose behind it, or their stated purpose behind it, I agree with. But apparently their methodology has failed. Distributive property. Let's get into this before I forget. Why do we get into algebra and we do the distributive property? Why? Why are we doing this? It turns out you've actually been doing it all along. When we do multiplication, long multiplication, 22 times 15, we are actually doing 22 times 10 plus 5, which is what the distributive property is all about. So for 3 or 4 years, we do the distributive property without knowing we're doing it. Then we throw letters together. A times B plus C equals A times B plus A times C. And it makes no sense because, again, why are we throwing letters in when we're supposed to be dealing with numbers? Reality of the matter is we've done this with numbers all the time. We just didn't point out we were doing it with numbers. 22 times 15 is 22 times 10 plus 5, which is 22 times 10 plus 22 times 5. Oh, it suddenly makes sense now. And that's the sort of thing, I realized this like my junior year in high school, and I was thinking, if they had taught me this back as a freshman when we started on this, instead of making me realize it on my own, it would have been a lot easier. I would have gotten higher grades. And the kids who complained about math might have not complained as much about it because it would have made more sense to them. I could be wrong on that. Some kids are going to complain no matter what. Some kids aren't going to get it no matter what, no matter how you teach it. But for a lot of kids, I think it would have made things easier. So there we go. It's math. We do have to slow it down a little so we can explain things better. But we still have to at the same time keep up a certain level so when people graduate they can do a certain amount. So like I said, math is harder to reimagine, but at the same time I can make suggestions, which I have. And that's basically explain how we're going to use it more than just how to do it. And again, story problems do this. Unfortunately, they never really told us how to do story problems properly. So everyone hated them. Looking back, it's like if I had seen this all one at a time as I see it being used, it would have made more sense. I would have done better. Would have enjoyed math better. I always enjoyed math up to a point, but there were always problems with it. So that's it. Like I said, not as much as I could have said. Could have gone through a lot more examples of stuff if I had taken the time to write them down, and also could have bogged us down an extremely long amount of time, which would have bored people. So that's how I would reform math as best I could. Have a nice day.